In this video, we'll study the data transfer instructions and arithmetic instructions of 8051. So first we'll see the data transfer instructions in 8051. The first instruction we have is MOV destination byte, source byte. So the instruction has two operands. The function of it is move the byte variable. So the byte variable, which is indicated by the second operand, it will be copied to the location which is specified by the first operand. So this instruction will copy a byte from the source location to the destination location, and the data in the source location will not be affected. No other registers and flags will be affected by this instruction. So we have the instruction in 4 different formats if accumulator is the destination. So the 4 formats are move a comma hash data, move a comma rn, move a comma direct, move a comma at ri. So we have the 4 formats when the destination is accumulator. So first one we have is move a comma hash data. So the example is move a comma hash 10h. So the data or the value 10h is copied to the accumulator. And then we have move a comma r2. So the content of register R2 is copied to the accumulator. And then we have move a comma 25h. So the location 25h is accessed and the data in it is copied to accumulator. And then we have move a comma at R1. So the memory location pointed by the register R1 is accessed and the data from it is copied to accumulator. Next format is when the accumulator is the source. So we have 3 formats, that is move rn, a, move direct, a, and move at ri, a. So example is move r2, a. So the content of accumulator is copied to the register R2. And then we have move 20h, a. So the content of accumulator is copied to the memory location 20h. And then we have move at R1, a. So the content of accumulator is copied to the location pointed by the or specified by the register R1. Next we have when the register is the destination. So we have the following 3 formats: move rn, hash data, then move rn, a, then move rn, direct. So directly the value can be copied to the register and accumulator content can be copied to the register and the memory location can be accessed and its data can be copied to register. Next, when the direct address is the destination, we have the following formats of move instruction: move direct, hash data, move direct, at ri, then move direct, a, then move direct, comma, RN. So we have example, move 30H, comma, hash 10H. So 10H is the value because it is preceded by the hash symbol, whereas 30H is the memory location. So the value 10H is copied to 30H memory location. Same way we have move 30H, comma, at R2. So the content in the memory location specified by the register R2 is copied to the memory location 30H. Then we have move 30H, comma, A. So the content of accumulator is copied to 30H location. And then we have move 30H, comma, R2. So the content of register R2 is copied to 30H memory location. Then when the destination is indirect address which is specified by the register R0 or R1, we have move at RI, comma, hash data, then move at RI, comma, A, then move at RI, comma, direct. So the example is move at R0, comma, hash 20H. So the value 20H is copied to the memory location specified by the register R0. Then we have move at R1, comma, A. So the accumulator content is copied to the memory location specified by the register R1. And then we have move at R0, comma, 30H. So the content of 30H memory location is copied to the memory location specified by the register R0. The next instruction is move destination bit, comma, source bit. So the function of this instruction is to move a bit of data. So it will copy the boolean variable which is specified by the second operand into the location specified by the first operand. So the source bit will be copied to the destination bit. So one of the operands should be the carry flag and the other can be directly addressable bit. No other registers or flags will be affected by this instruction. So the example is move P1.3, comma, C. So this will move the carry bit to the D3 bit of port 1. Similarly, we have move C, comma, P2.5. This will move the D5 bit or copy the D5 bit of port 2 to carry bit. Next instruction is move dptr, comma, hash data. This is the 16-bit value or 16-bit constant. So the function of this instruction is to load the data pointer with a 16-bit constant. So the data pointer register will be loaded with the 16-bit immediate value. So the 16-bit value will be loaded into the second and third byte of the instruction. So the second byte, that is DPH, data pointer high, will be the higher order byte, and the third byte, that is DPL, data pointer low byte, holds the lower order byte. No other flags will be affected. So in the move instruction, the second byte will be the higher order byte, that is DPH, and third byte will be the lower order byte, that is DPL. And using this instruction only, we can move 16-bit of data at once. So the example we have is move dptr, comma, hash 4567H. So this will load the value 4567 into the data pointer. So the data pointer higher byte DPH will hold 45H value, and data pointer lower byte DPL will hold 67H value. Next instruction is move C A comma at A plus DPTR. The function of this instruction is to move code byte. So this instruction will move a byte of data which is located in internal ROM space into the register A. So the address of the desired byte in the code space or on-chip ROM, it is formed by adding the original value of the accumulator to the 16-bit data pointer register. So we access the internal ROM space and the data is transferred using this instruction to accumulator. Similarly, we have the next instruction move C A comma at A plus PC. So the function of this instruction is to move code byte. So this instruction will move a byte of data which is located in program area to register A. So the address of the desired byte of the data, it is formed by adding the program counter register to the original value of the accumulator. So here the program counter will be used to generate the data address instead of data pointer. Next instruction is move X destination byte comma source byte. So this instruction will move the data from or to the external memory. So this instruction will transfer the data between the register A, that is accumulator, and the external data memory. Since external data memory is being accessed, we have the X appended to move. So the external memory address can be 16-bit or 8-bit. So if the external memory address is 16-bit, then it can be held by the data pointer register DPTR. So we have the instruction move X A comma at DPTR. So this instruction will move the data from the external memory whose address is pointed or held by the data pointer to the accumulator. Similarly, we have move X at DPTR comma A. So this instruction will move the data in the accumulator or content of the accumulator to the external memory location whose address is held by data pointer. When the external memory address is of 8-bit, we have the registers R0 and R1 to hold that address. So we have the instruction move X A comma at Ri, where I is 0 or 1. So this instruction will move the byte from the external memory whose address, that is 8-bit address, is pointed by the register R0 or R1 to the accumulator. Similarly, we have move X at Ri comma A. So this instruction will move the byte or data from accumulator to the external memory location whose address is held by register R0 or R1. Next instruction is push direct. So the function of this instruction is push onto stack. So the stack pointer will be incremented by 1 and then content of the indicated variable will be copied to the internal RAM location addressed by the stack pointer. No other flags will be affected. Similarly, we have the next instruction pop direct. So the function is to pop out from the stack. So the contents of the internal RAM location which is addressed by the stack pointer will be read and the stack pointer will be decremented by 1. The value which is read, it will be transferred to the directly addressed byte indicated. No other flags will be affected. Now let us see the arithmetic instructions in 8051. The first instruction is add A comma source byte. So the function of this instruction is to perform addition. So the instruction will add the byte variable specified by the second operand to the accumulator, and the result will be stored in the accumulator. So due to addition, we have to check the carry flag and auxiliary carry flag. So the carry flag, it will be set when there is carry out from the D7 bit, and auxiliary carry flag, it will be set when there is carry out from D3 bit. Else the carry flag and auxiliary carry flag will be cleared. So for unsigned integer addition, the carry flag will indicate that overflow has occurred. So the overflow flag, it will be set when there is carry out from D6 bit but not from D7 bit, or there is carry out from D7 bit but not from D6 bit, else the overflow flag will be cleared. For signed integer addition, the overflow flag indicates a negative number produced as the sum of two positive operands, or a positive sum from two negative operands. Add instruction, the source operand, it can be having the four addressing modes used, that is register, direct, register indirect, and immediate. So the examples are add a comma hash data. So we have the immediate data as the second operand, and then we have add a comma rn, that is register addressing mode. Then we have add a comma direct, that is direct addressing mode. Then we have add a comma at rn, that is register indirect addressing mode. So the example is add a comma hash 20h. So 20h will be added to the accumulator content, and the result will be stored in accumulator. Then we have add a comma r0. So the content of r0 register will be added to accumulator, and the result will be stored in accumulator. Then we have add a comma 30h. So the memory location 30h will be accessed, and the data in it will be added to the accumulator content, and the result will be stored in accumulator. Then we have add a comma at ri, where I equal to 0 or 1. So the memory location which is specified by the register R0 or R1, it is accessed, and the data from it is fetched, and it is added with the accumulator, and the result is stored in accumulator. Next instruction is add C a comma source byte. So the function of this instruction is to do addition with carry. So the instruction will add the byte variable specified by the source byte, accumulator content, and the carry flag, and the result will be stored in accumulator. So the content of accumulator will be added to the byte variable specified by the source byte along with carry flag. So the carry flag, it will be set if there is carry out from D7 bit, and auxiliary carry flag, it will be set if there is carry out from the D3 bit. Else the carry flag and auxiliary carry flag will be cleared. For unsigned integer addition, the carry flag indicates that overflow has occurred. The overflow flag, it is set when there is carry out from D6 bit but not D7 bit, or there is carry out from D7 bit but not D6 bit. else the overflow flag is cleared. And while adding signed integers, the overflow flag indicates that negative number is produced as the sum of two positive numbers, or positive number is produced as the sum of two negative numbers. Let us see an example for the add C instruction. So clear C, then move A comma hash 30H, and then add C A comma hash 25H. So the add C instruction will perform the addition of A plus 25H plus carry flag. So we have A equal to A value is 30H plus the second operand is 25H, and then the carry flag is 0. So we have to add 30H plus 25H. So we get it as 55H, which will be stored in the accumulator. Similar to add instruction, in add C instruction, the source operand can have four addressing modes, that is register, direct, register indirect, and immediate. So the example is add C A comma hash data, add C A comma RN, add C A comma direct, then add C A comma at RI. Next instruction is sub B A comma source byte. So the function is to subtract with borrow. This instruction will subtract the indicated variable, that is variable indicated by the source byte, and the carry flag from the accumulator, and the result will be stored in the accumulator. So the steps for subtraction, it is as follows. First, take the 2's complement of the source byte, then add it to the accumulator, that is register A, and then invert the carry flag. So the operation done is A equal to A minus the source byte variable minus the carry flag. So the carry or borrow flag, it will be set when there is borrow needed for D7 bit, and auxiliary carry flag, it will be set when there is borrow needed for D3 bit, else the carry flag and auxiliary carry flag will be cleared. Similarly, the overflow flag, it will be set if there is borrow needed for D6 bit but not D7 bit, or borrow is needed for D7 bit but not for D6 bit. The four addressing modes which are used for the sub B instruction are immediate, register, direct, and register indirect. So we have the instruction written. So sub B A comma hash data for immediate addressing mode, and then sub B A comma RN for register addressing mode, then sub B A comma direct for direct addressing mode, sub B A comma at RI for register indirect addressing mode. So the example is sub B A comma hash 25H. So this will perform A minus 25H minus carry flag, and the result will be stored in A. Similarly, sub B, A comma R2. So this will perform A minus content of R2 minus carry flag. And then sub B, A comma 30H. So this will perform A minus the data in the location 30H minus carry flag. Then sub B, A comma at R0. So this will perform A minus data at the location specified by R0 minus carry flag. Next instruction is swap A. So the function is to swap the nibbles within the accumulator. This instruction interchanges the lower nibble, that is lower 4 bits D0 to D3 with the upper nibble, that is higher 4 bits D4 to D7 within the accumulator. So if suppose we have the accumulator content as 59H, then after swap operation the content in accumulator will be 95H. So the lower 4 bits will be swapped with the upper 4 bits. Next instruction, XCH A comma byte. The function is it exchanges accumulator content with the byte variable. So this instruction, it loads the accumulator with the content of the indicated variable specified in the second operand, and it writes the original accumulator content to the indicated variable. It means it swaps the register A content with the indicated variable. The source operand or the source byte, it can use register direct or register indirect addressing mode. So we have XCH A comma RN, XCH A comma direct, and XCH A comma at RI. Next instruction is XCHD A comma at RI. The function is exchange digit. So this instruction, it exchanges the lower order nibbles of the accumulator, that is bits D3 to D0 with that of the internal RAM location, which is addressed by the specified register, whereas the higher order nibbles bits D7 to D4 of each register, that is of the accumulator and the data in the internal RAM location, are not affected. Next instruction is CPL A. The function is complement accumulator. So this instruction, it logically complements each bit of the accumulator, that is it performs one's complement. So if the bit was 1, it will be changed to 0 and vice versa. Next instruction is CLR bit. So function is clear bit. So this instruction, it clears a single bit. So the bit, it can be a carry flag or any bit addressable location in 8051. So we can have the instruction as CLRC, it can be used for carry flag, and we can have CLR P2.4. So it is for bit addressable location. So CLRC, it will clear the carry flag. So carry flag will be made 0, and if it is CLR P2.4, it will clear the D4 bit of port 2. Next instruction is DAA. The function is decimal adjust accumulator for addition. This instruction, it adjusts the 8-bit value of the accumulator, which is resulted from the addition of two variables which are in packed BCD format, and produces two 4-bit digits. So this instruction is used after the addition of BCD numbers to convert the result back to BCD format. So after the addition process done using the add or addC instruction, we use this decimal adjust instruction. Next instruction is DEC byte. So the function is decrement. So this instruction, it decrements the indicated variable by 1. That is, it subtracts 1 from the byte operand. So if the value was 00, then after this instruction, the value becomes FF. The carry flag will not be affected by this instruction. So this instruction, it has 4 addressing modes used. So we have DEC A, we can have DEC RN, we can have DEC direct, we can have DEC at RI. So we can decrement the accumulator content by 1, and we can decrement the register content by 1, and we can decrement the byte in the RAM location specified by the direct addressing mode, and we can decrement the content in the memory location pointed by the register RI, which is R0 or R1. Next instruction is INC byte. So the function is increment. This instruction, it increments the indicated variable by 1. So if the value was FF, after this instruction it becomes 00. So it adds 1 to the indicated variable. So we have this instruction used in 4 addressing modes. So we have INC A, then INC RN, INC direct, and INC at RI. Next instruction is INC DPTR. The function is increment data pointer. So this instruction, it increments the 16-bit data pointer register by 1. So if there is an overflow in the lower order byte of the data pointer, that is DPL, that is from FF to 00, then it will increment the higher order byte of the data pointer, that is DPH, by 1. So no other flags are affected by this instruction. So the data pointer register, it can be only incremented. Next instruction is div AB. The function is divide. So this instruction, it divides the content of accumulator by the register B content. That is, it divides the unsigned 8-bit integer in the accumulator by the unsigned 8-bit integer in the register B. So the accumulator will have the result of the division operation, that is the quotient, and register B will have the remainder. Both the carry and overflow flags will be cleared in the division operation. Whereas if the register B has the content 00 in it, then after the division operation, the values returned to the accumulator and the register B will be undefined, and the overflow flag will be set, whereas the carry flag will be cleared. So overflow flag will be set to indicate that the result is invalid, since the divisor, that is the register B, is having 00 value. Next instruction is MULAB. So function is multiply. So this instruction, it multiplies the unsigned 8-bit integers in the accumulator and the register B. So the product of multiplication, that is 16-bit product, it will be stored in the accumulator and the register B. So the accumulator will hold the lower order byte of the 16-bit product, that is lower order 8 bits, whereas the register B will have the higher order byte of the 16-bit product. If the result is less than 255, that is if the product is less than 255 or FFH, then the carry flag will be cleared and overflow flag will be cleared. Suppose the product is greater than 255 or FFH, then the carry flag will be cleared, but the overflow flag will be set. Next instruction is NOP. The function is no operation. This instruction performs no operation and the execution it continues with the next instruction. So this is used sometimes for timing delays, and this instruction it can only update the program counter to point to the next instruction following the NOP. No other register or flags are affected.